all of you kindly accept the consent pop-up that shows to you for the recording. All right, we'll figure out the muting part. Mute all.
Okay, sir.
Don't see it here. Okay, right now, let's move on and then we'll figure it out.
Yes, sir. Yes, sir. So shall we start the session, sir? Meanwhile, others may join. I'll admit them.
Please.
Yeah. Good morning, everyone. I welcome you all to this session on introduction and state of the art in AI and ML. So let me take the privilege to introduce our visiting faculty, Mr. Venkateshwar Reddy Mela Chervu. Good morning, sir.
Very good morning, Professor and students.
Yeah. So I take it a privilege to introduce Mr. Venkateshwar Reddy Mela Chervu. Sir is a passionate and results-driven technology leader with extensive experience in product engineering, technology application, and leadership. So he has a proven track record in delivering cutting-edge solutions that drive operational excellence, profitability, and innovation. Sir has a huge expertise in the software industry. So let me share you his work experiences. Currently, sir is working as CTO at Brillium Technologies. And also, sir, are you able to hear me, sir?
Yes, I went on mute. Please go ahead.
Yeah, thank you. Right. So, sir is currently working as CTO at Brillium Technologies, Bangalore since September 2024. It's like, almost 1 year ago. Then he is a member of CXO Club. He is Everwise mentor. He was CTO at BeLive. He also worked as CTO to Metronomic Technology Solutions, CTO for ReadyWire, technology advisors at Kavichi, technology advisor at GoActive, and he was also a CTO at Unifies, CTO for Drug Hub Technology Private Limited, CTO for LRC EduTech Private Limited, and many other companies. So coming to his educational background, so sir has did his masters from Indian Institute of Technology, Kanpur, and his areas of interest included were next generation wireless technologies and communication system. And I am very much proud to say that he is our alumni of the batch 1988 to 1992. He pursued his BTech from Electronics and Communication Engineering in G. Pullareddy Engineering College. So with his vast expertise, Sir has readily accepted our request, and he started working on delivering the lectures on the subjects which we have requested, and he is continuously from the past 1 month he is working on this, and we are very much glad to have you here, sir. So I sincerely thank from our end for accepting our invitation and ready to take these sessions on AI, UP, and ML related topics. And students, I guess definitely you all will get benefited with the topics that sir will discuss. And please try to complete the assignments or whatever the things that sir has requested you and submit them on time. With this brief introduction, let me request Venkateshwar Reddy sir to take over the session. Please welcome, sir.
Thank you. Thanks for those kind words and thanks for that introduction, Professor Suresh. Good morning, students. And it feels really more than happy to me to be talking to you, to be sharing some of my thoughts and experiences with all of you, particularly the fact that I have been the alumnus of this college, like Professor Suresh mentioned. And also it makes me feel, as if I'm still, or rather, as if I'm just getting started my college. Thanks for that energy vibes that the college and all of you guys are bringing in. Because the topic of AI is my not only passion, and focus of our interest, both in my personal pursuit as well as in my professional pursuit in the company Brilliant Technologies, where we try to build solutions that would leverage Gen AI for the businesses and also for the society. Thank you so much for reaching out to me to be the guest lecturer. I appreciate that. And I'm super excited to share my experiences and then my thinking with all of you guys in the next 10 to 12 sessions, out of which a couple of them would be online, face-to-face with you in person in the college. In fact, we plan to do it this session, inaugural session as well from the college, but the logistics and particularly the festival, Vinayak Chaturthi festival, could not, allow us. All of you guys needed to go back home and celebrate this. So the intent is to complete in 1.5 hours. We've already taken up around 20 minutes, 25 minutes to be precise. So I'll try to wrap it up as soon as possible. So the topic of today, but before that, a couple of gotchas of this meeting. I would like all the sessions of mine to be interactive. We'll talk about session structure, this program, how many sessions are going to be there, what are these sessions, what are these projects, etc. Some of you might have already seen the Google Classroom, where we have completely published the first course handout as well as the schedule of each topic/project. So I'll delve into them onto those topics as well. So let's get started with the session today, in which I would like to share with you what the heck is AI and what is ML and what is generative AI that you probably might be hearing, and what is general artificial intelligence that some of you might have heard that the world is moving towards, and what is the state of art of these technologies. How will it help? Why should we worry about it? How would machines, or how can machines have intelligence? Even before intelligence, how can machines learn? Because intelligence in a way is nothing but learning, probably at a different speed. If somebody learns faster, we call him smart and intelligent in our real lives. And if somebody learns with some sort of working and studiousness, we still call it intelligence. So how would machines get that trait, right? All those questions I would like to unravel in a simple terms without using much of the technology, which would serve as the basis or as a foundational understanding for all of you in the 5th semester for your core focus of this branch or your undergrad study, which is artificial intelligence, right? And I would also talk about future direction of the AI. I would also talk about what are the risks, what are the limitations, what are the challenges of the AI. And I would also delve into some of the key concepts that are kind of really fundamental for the AI and machine learning, and that are something that you should have some idea about in today's state-of-the-art AI, like LLMs, the GPTs, and the transformers. In fact, some of these technologies, particularly transformer, is something that has been probably, we can say, invented by one of the Indians, Vaswani at Google DeepMind. In today's world, particularly with the generative AI, you don't need investment. All you need is your brain, your research, and your common sense approach to solve a problem. because most of the work that has been done so far is available to you as an API. You would see that as we build projects, it does not require a lot of understanding or a lot of code for you. All it requires is to just include a library and understand which is the right method to call from that library, and then supply the necessary parameters of the data set and configure that API call with certain parameters, which we call it hyperparameter. So all it requires is imaginative thinking with an objective to solve the problem. Right? We'll address that part, those core key concepts that would enable you to be able to get to that point of creating some tech or creating something that nobody has been able to create so far. And of course, I'll spend some time in providing the overview of the advanced or applied AI and ML industry projects lab. Intent is to build this as a program/lab where all those interested students, as well as part of the curriculum, the guest lectures are run, and those that are interested in building projects in generative AI or in any other sub area of AI can start building it under my guidance. And of course, in the end, I'll keep aside around 5 to 10 minutes for the Q&A. And then I would obviously get to the call to action for you guys for the next 12 weeks of this program. What is expected to be done, how you can gain most out of this session, out of these sessions that each Saturday and Sunday, and probably a couple of Mondays as well in a work week, that you would end up spending with me. All right, all of you are good to get started? Are you guys still sleeping in a sleepy mood of Sunday morning? I don't hear not a single yes or no.
Yes, students, you can unmute yourself. You can answer.
So guys, all of you had breakfast?
పెట్టు ఇద్దరు ఒకేసారి అన్మ్యూట్ చేసేస్తారన్న.
Looks like I think most of you are on mute. Nonetheless, so a couple of the housekeeping work for this session. I would expect all of you to be voluntarily be on mute when not speaking. And if you have any question, please do not hesitate to interrupt me by raising the hand and unmuting yourself when asked to speak. And then after your question is addressed, or if you have something to say that has been addressed, please mute yourself. So I hope all of you will follow this. And good morning to you all. I would like to hear at least a couple of good mornings back from you guys. No? All right. Looks like you guys prefer to type rather than speak. That's fine. I hope we don't end up in the film like that. What was it, Dale? Where everybody starts only chatting but not talking. Anyways, let's get going. So next couple of minutes, I'd like to tease you, and I'd like you to, whoever is interested, respond with your thoughts on these questions. What is AI? It's intelligence, but it is artificial. But what is artificial intelligence? When we say intelligence, essentially there is some sort of thinking, some sort of knowledge, some sort of inference, some sort of learning, some sort of emotion Not always what we say, what we think are just purely without any emotions, right? So what is AI? Which requires thinking, but how do machines think? Can anybody want to share your thoughts? I would prefer you guys speak, unmute and speak.
Guys, please unmute yourself and you can answer the things instead of typing.
Anyone? No one wants to share? Go ahead. Someone wants to share.
Good morning, sir.
Good morning. Go ahead.
Sir, I think AI are the machines that think rationally and act rationally at any situation, sir.
Okay, a very interesting response. But how would a machine think rationally? Where does the machine derive the rationality? And what is rationality? Anyone else or yourself?
Sir, it can make machine to think rationally by giving some task and giving performance measure to it, sir. Like giving a point if it does correct or like that, sir.
But
Sir,
can machines think rationally today?
yes, sir, most of the time.
Well, it's a debatable question. Rationality is reasoning, and reasoning is driven by not just learning and correlating decision making to what has been learned, which is essentially a correlation to the past learned information. But rationality goes beyond the correlation. It goes into what we call it cause and effect. Rationality also has some sort of subjectivity where objectivity tries to overpower the subjectivity. We will also spend some time in terms of what AI study, how AI comprises of various sciences under the sun today, because AI comprises and cuts across all studies of science, all forms of science. So let us try to put a few key terms which would serve and which essentially world is trying to solve in AI today, right? You're right. It tries to think, but how does it think? It thinks based on learning that it has accrued by looking at some past data, lots of data, right? And it also has to be intelligent in terms of taking the right, most optimal decision for a given task at hand. And it also means performing tasks efficiently, consistently, right? But in today's world, machines focus in applying that reasoning or whatever level of rationality that we have achieved to implement in machines in a non-imperative programming paradigm is mostly related to or constrained to recognizing the patterns in the data that the machine goes through and using that patterns either to predict a value or to predict the probability of something better amongst the available options is what machines are successfully with high accuracy be able to achieve today. That is the state of art today in terms of the machine's thinking. Essentially, it boils down to arriving at some sort of statistical analysis of the data that the machines have been fed up with, which we call it training, identifying the patterns and then the distributions. Most of you must have studied all these Gaussian distributions and various distributions. These are the fundamental blocks of analyzing tools, mechanisms that today's cutting edge machines, inclusive of the chat GPTs of the world, use to generate synthetic data. Essentially, ChatGPT is nothing but which generates your next word continuously for a given window of 2,000 words, 4,000 words, based on the distribution and pattern that it has seen and learned when it was trained with petabytes of data across Wikipedia, entire web data, lots of research papers, you name it, YouTube, audios, videos, etc., etc. Right? So machines are still not able to go beyond these, if you want to call them as correlational decision making or inference, which is essentially given by mathematics. And they are still to get the human rational decision making of cause and effect. Each effect has a cause behind it. In a way, it goes back to, some of you might have studied Markov chains, right? Essentially the Markov decision making process, where your future action is most of the times, or pretty much, is only dependent on the present action, but not much of past. But if you create a chain, it goes all the way back, which we call it in our Hindu philosophy that any action we take today is a result of what we call it karma, not only the past action of yesterday or yesteryears, but probably also from the previous Janma of ours, right? Previous carnation of ours. So machines have not gotten to that yet. And it's just a matter of time, probably, that machines may get to it, but it's most complex. And it's not something that I would imagine it would happen tomorrow or in the next 10 years. It's going to take some time. But machines can become or can develop sentient, feeling the sensation. There are sensors today that can, if you get into big IT tech parks and in the washrooms, you see that many of these machines keep sprinkling a fragrance whenever they feel the odor level goes up, right, in the toilets. So they are sensing the smell, they are sensing the level of the smell. All these can get infused into, a single technology block someday, right? Can machines understand the language that humans speak and write? Most of the times, English or any native language. Anybody want to answer that? Or share your thoughts? No? So try to make it interactive, guys. These are the sessions. These are the sessions meant to bring out your gray cells, your intelligence levels out on offhand, impromptu. And that is what the intelligence and smartness is. In real life, when you come out of the college, there is no book to prepare for any task that your manager gives or your company gives, or even in life. The smartness and the intelligence is nothing but applying what you've learned, whether in the school or whether in the life so far, applying to solve or to address a challenge thrown at you in any context, in any instance at that time, right? So I would like to make it as interactive as possible, brief, and it's a request. So make use of it, because this would make you the best person professionally to be able to address and handle any situation in your career as you start and embark and evolve your careers, right? So machines, to greater level, understand the language, which started as a science called NLP, natural language processing. It is in a way nothing but many complex rules, isn't it? English language is driven by grammar. Grammar is nothing but your syntax of your language, which is like your syntax of your computing language. But there is a semantic meaning, meaning a certain sentence can be said at certain situation, cannot be said at the other situations. So understanding that contextual meaning is something that humans build fast, human brain, whereas machines are evolving, and we are bringing, injecting that intelligence to be able to understand the context and then provide responses using NLP by means of these evolutions that you're witnessing, which is chat GPTs of the world, clouds of the world, or Google Geminis of the world, right? Right. So let's also address a couple of questions before we get into the next topic. How do algorithms, AI algorithms, recognize the faces and the voices, right? And today, you have seen lots of online portals where you can upload the image. Google itself, there is an image search, which probably, I think they started around 1 to 2 years back after the COVID. Now you upload an image and you can get similar images. How do they recognize? In fact, biometric authentication using your face, retina, has been there for so long, right? So how do they recognize these faces or images, or even the voices for that matter? Voice recognition is used also for so many years, though it is in a very narrow way. But today it is becoming more widespread in recognizing just a simple low quality voice, even from the telephone conversations. How is it possible? How are they machines able to recognize these various types of information? Anyone want to address that? Share your thoughts. Well, so it is possible using, again, mathematical tools. And particular mathematical tool that is implemented to recognize faces or to recognize patterns is based on the pattern analysis. There is a pattern in anything, particularly the image pattern. Image for us is a 3D picture. Physically, we can feel, we can see. But for a machine, it is nothing but pixels of either a 2-dimensional or 3-dimensional information of pixel, right? Picture element, whether it's gray, green, various colors, depending upon how many levels of resolution each pixel represents, from a simple 1 bit, which is gray, black, or white, or 2. I think you can support up to 64-bit resolution today, or beyond that. Retina, all those OLED, etc., achieve billions of color variations per each pixel, right? So identifying the pattern of such pixels, which again goes back to some sort of distributions and pattern analysis. Essentially, the foundation is pattern analysis, which is possible through some of these neural networks, like convolutional neural network or recurrent neural networks, right? And even for the voice, same case, with whether hidden Markovs or some of those HMM models, etc., or Gaussian mixture models, etc., GMMs, right? So is AI just a tool, or is it more than a tool? This I would like to address towards the end, but definitely it's not just a tool. It has become pervasive. It is part of any product, any solution that today that you see or you lay your eyes on, right? It has become pervasive, it has become ubiquitous, and it is part of everything. It is finding its way into each nook and corner of the life today. In fact, the picture that you're seeing here, it is a picture that represents the concept of fusion of a physical mind, human brain, and a digital network. You know what? I did not create it. Nobody created it. I actually asked Google Gemini to give me a picture by giving a prompt. You can you try yourself. I'll be sharing this presentation in Google Classroom, and I have given the prompt here, as you can see. You guys can try it out. Go to Google Gemini and then ask this question. It has been generated by the Google Gemini. Imagine just by saying few words what you want, and the machine generating an artwork. It is a still image, but probably some of the other, like Mid Journey, right? They can generate audio, video based on the text description and even audio description. That is the level of evolution of AI that we are witnessing. So much so that Andrew Ng, I'm sure most of you know, is the co-founder of the Coursera, is also adjunct professor of Stanford, and he worked for Baidu, and he is an AI pioneer. He said that, quote unquote, artificial intelligence is the new electricity, right? When electricity was invented by, was it Edison, Thomas Alva Edison? The people felt it is like a magic, right? It is like some evil magic. Many of them were opposing this as well, right? But it was a great invention, without which probably none of what we take it granted, make it necessary to live and survive, would have been there. Without electricity, will never be there, right? AI would become such pervasive as electricity for the future, not only for future generations. In fact, it is becoming already. That is the significance and the power of AI today, right? So let me go to the next. Right. So to address what is AI, AI is a branch of science, particularly computer science engineering, and is an intersection of many other sciences: cognitive science, language science, neurobiology, neurons, right, brain, philosophy, the cause and effect we talked about, psychology, subjectivity. Psychology essentially is to understand how people become or have varying levels of subjectivity and objectivity, how a psyche works, what I think for a given, what I respond to for a given situation would differ from what you respond. This is all psychology or the traits of that person. So that is also important for AI to be able to understand, comprehend, and respond to the humans, to achieve the levels of non-human interventional decision making for the useful tasks that the human assigns to, right? Essentially to mimic the human brain or cognitive function. Brain, essentially the functioning of the brain is highly cognitive, or it requires the cognition of the world, cognition of the matter, everything cognitive to understand that matter, that topic, which comes from learning, which comes from applying the learning to decision making from the past experiences, etc. And essentially the learning, reasoning, solving the problems could be real life or could be theoretical and could be from the business, and also to be able to perceive. Perceiving is not just seeing. Perceiving is not only seeing, but going beyond seeing, going behind what is being seen, the reasoning behind it, the cause behind it. And also to obviously understand, for all of this would require understanding the language that the humans speak, humans write. Predominantly and unfortunately today, it is driven by the universal language which the West started imposing and now has become a de facto standard, which is English. Right. So there are a lot of effort and endeavors across the globe to build, each country's language as one of the languages that the computers can recognize. Right. So essentially, AI is a multidisciplinary science. It is a science, and it is making strides. Right. Also, one of the questions that most of you would have, will have, and may not have that clarity. Particularly, you have data science branch, there is an AI branch, there is an ML and AI branch, and then there is a core computer science engineering branch, and some of the universities also have deep learning specialization, data analytics specialization. How are all of these related? They are related, and this visual is my attempt to bring that understanding of how they are related. So it is like a universe of sciences, particularly related to data. Data is everything. Data, what we speak, what we write, how we behave, what we have written. For example, the recording that of this session someday may become a training material for ChatGPT 5, right? Because there is a knowledge imparted, and there is an expression of that knowledge imparted to the students who are trying to learn or understand. That could be, there could be a pattern in it, and that the machine can identify that pattern from the voice and also from the slide deck that I'm using, right? So data is the key. So everything and anything is connected and driven, and underlying the pedestal is the data. And that data is huge, and we need to process that. Hence, it is a big data. How you process huge amounts of data in your limited compute resources, be it your processor, be it your RAM, be it your bus that connects your CPU to your RAM, which operates today at probably 4 to 6 gigahertz, at the most 6 to 20 gigabits per second. You can't go beyond that. The speed of thinking, right? And then that's the speed of transport. And then you have to crunch those numbers, do some mathematical operations. So again, there is a added overhead to it. So your net result of processing is less than few gigabits per second, right? So data is underlying pedestal or the base, and all of these sciences in a way intersect. AI uses data science of how to collect data, how to analyze the data, how to mine the huge data, how to build analytics out of this data. Analytics as in meaningful insights, right? And how to take out the noise from this data. What are all the scientific methods, statistical, mathematical, probabilistic, right? And then how do we represent data as a knowledge? Data has no meaning. It's just bits, essentially, or bytes. But how do you represent this as a knowledge in a computing environment itself, in a persistent, non-retrievable form, so that you can have semantic processing of the data rather than mathematical processing of the bits and bytes, right? And that would be faster. Humans essentially process in a semantic way rather than a simple mathematical way of the additions and subtractions or the multiplications or the divisions. How can we achieve that level of human quotient of semantic processing of the information, right? And how do we learn? How do we deep learn? How can we learn peripherally? How can we make decisions involving real life data? All these are on the left side is essentially the artificial or the intelligence, which essentially when we try to build algorithms and the software to help machines make those decisions or help us make those decisions under our guidance and our instructions, under our control, is essentially the subject and the study of artificial intelligence, trying to bring in the human cognition as well, right? The other representation has an intersection of various sciences, where there is the statistics, mathematics, and some of these areas that I have already addressed. The idea here is to bring in various sciences and how the AI and computer science intersect. Obviously, AI is a subfield of the computer science, machine learning, deep learning, generative AI, etc., are direct subfields of the artificial intelligence. Data mining, statistics, analytics, data science, mathematics are part of the data science, which have a strong intersection and strong benefits or strong usage in the AI and in the computer science, right? So what are the capabilities and the types of the AI systems that are prevalent today globally in the market? Today, the fourth phase of AI, we'll get to that various phases. So the capabilities of AI today, some of them I have addressed in a very succinct way. The AI today is mostly narrow intelligence. It is mostly a task-based intelligence. Recommending, for example, a specific movie for you, like the Netflix recommender or Amazon's recommender. Hey, look, you're trying to search for this product. There are 1,000 people bought this. Along with it, they bought these items which would be useful. It's a kind of recommendation. And this is a direct application of artificial intelligence. It's not just simply some rules that they have built in. It's beyond the rules, identifying the patterns of the other users who have the similar profiles as you, right? So today, it is mostly related to narrow intelligence, a defined set of tasks. For example, robots, if you look at manufacturing, probably Tesla, the electric vehicle or car manufacturer, 90% of its assembly line is done with robots. Assembling any component of the electric vehicle, probably more than 90% is completely automated with robots. These are purpose-built machines. They're like computers, but they have sensors, mechanical parts that have been installed with the software, which is artificial intelligence software, to be able to assemble that specific component in that step or phase of the assembly line. Right? So it's a narrow intelligence. The world is working towards artificial general intelligence. That is the buzzword today that the people and the technology is trying to build towards, where people are trying to simulate the intelligence and the cognition of the human mind across the wide spectrum of tasks, not necessarily a narrow set of tasks. It goes beyond the wide spectrum of tasks. People are trying to build some sort of sensing, essentially, into this wide or wider intelligence. And of course, there is a conceptual thinking of probably, like I was saying the other day, a little while ago, that there may be machines may may evolve to become or to have super intelligence. What we meant by super intelligence there is building sentient, build identifying emotions, having its own self-awareness, right? Like a real human. Is it possible? It probably can go beyond human capability as well. Is it possible? I am doubtful. Definitely, human machines may be able to get to the level of human cognition, but can they go beyond human sentience and the human capability? I am not a believer in that at this point, but you never know, because it is essentially going beyond human, is essentially becoming nearer to being God, right? Is it possible? Probably there would be efforts, endeavors, and we've all seen these, these stories and the movies, and somebody trying to kill 1,000 people to become super god, or somebody trying to perform massive level of pujas, etc., to become super god on a dark, Amavasya night, if you guys are familiar with. All these people tried, in a way, doing that in a high-tech world. Is that possible? Probably not. And I don't think it may happen in my view, right? So those are on the capabilities of the AI. What type of systems? How do we categorize based on the capability of the AI that we have today? What are all the systems? What are all the categories of the AI that are there today and that probably may be there in the future? They are classified into, today at least, categorized into 4 areas. And this is the latest hypothesis by a professor, Arend Hinzes, who is from Sweden. He works currently at Dalarna University in Sweden, but I think he used to work for Google or Princeton University earlier, or maybe Carnegie Mellon University till last year. It's kind of hypothesized into 4 systems: reactive. Essentially, reactive AI systems are classification, identifying the patterns, and then predicting something, predicting the text or next word sequentially, and then essentially they are pattern recognitions driven by mathematical parameters. Some of the imperfect scenarios, only certain information, not full information is given. They may be able to understand the problem based on the historical learning and provide a decision or inference for a given problem. These are the reactive. So they're reacting to the situation. They're not proactively working. So that is the reactive AI. And then there is another category. This exists today, reactive AI. Limited memory. So essentially, ChatGPT, in a way, a limited memory. And if you have tried ChatGPT 4, Omni 4.0, it says memory updated whenever you give a specific situation. So it's remembering each context, each prompt that you type in its memory. So it'll remember for a limited period of time. Essentially, it has to have that memory. And if you are running on a free service, it will be lesser than limited. And if you are running on a paid service, probably it is limited higher than what otherwise would be possible, right? So such machines can handle higher complexity and also have higher historical data, hence improved, enhanced decision making. Examples are self-driving cars, right? You've been hearing them, you've been seeing them. Google has been trying, Waymo and all those companies. And in fact, Mahindra as well has built a car, which I think around a few weeks back they have announced. Scorpio or some other model, or maybe X7 has driven few hundreds of kilometers without human in a traffic, right? So this is the current state of art in terms of the limited memory category. The next two categories are hypotheses, just like the capabilities, theory of mind, essentially achieving the level of human mind, and then being self-aware, sentient, and going beyond human capabilities are the other two categories of hypothesis. I am skeptical if self-aware machines would really exist to the level beyond the capability of human mind. They may exist some level of being self-aware, being aware of very limited, what should I say, limited sense of sentient, limited sense of or task-specific self-awareness. Excuse me. Or a narrow set of actions-related self-awareness, etc. Right. So let me quickly zip through. These are the subfields as exist today. As you can see, generative AI, and then the foundation of the generative AI, the large language models, LLMs, be it for vision, text, or for the multi-model, is part of the subfield today, right? And the core areas are more of a research areas, these are, and application areas of the general artificial intelligence. Kind of addressed them so far, but let's spend a couple of minutes here. Artificial intelligence, DL, deep learning and artificial neural networks, computer vision, robotics and intelligent agents, intelligent agents. For example, I'll talk about one specific use case as part of the reinforced learning later part of this session shortly. Vacuum cleaner is a best example of applying the technology to relieve the humans from the chores of cleaning your house, right? Natural language processing, text to speech and speech to text, without which these agents, some of you have sent your digital bots to participate in this meeting and then record, transcript this meeting so that you can read through the summary of this meeting later on at your convenience, at your convenient time, right? Expert systems and knowledge representation, reasoning, autonomous vehicles, augmented and virtual reality, and I'm sure most of you would have tried some form of the other of these core areas in your gaming. Most of you guys, I'm sure, I'm certain. And of course, social networks and graph analysis. Most of you use these social media where it'll automatically identify and say, hey, look, this person, you may know him because you've stored his number on your phone and you're running your FB app and it has recognized that. And it suggests, and if you make 2-3 calls to that person, and it starts building, or looks like you know this person, and recommends, hey, look, you may know this person. Do you want to connect to him? Be it LinkedIn, be it Facebook, right? So, and also how you're connected. If there is a person who is connected to your immediate relative or connected to your close friends, it may suggest, hey, look, you may know this. All this is coming from learning from these network of connections. The networks itself is a huge subfield of study, right, in computer science and engineering. So it's another way of depicting what we have addressed so far in terms of the core areas and subfields, but I wanted to draw one analogy and parallel of these stacked AI layers or the subfields to what you already know. Some of you might have studied as well, is the network model, be it the DoD TCP IP 5-layer model or be it OSI 7-layer model. Entire internet is driven by the DoD 5-layer model. If you look at the top layer, application layer in TCP IP, your applications like HTTP or mail protocol, SMTP, web protocol, HTTP, or for that matter, email protocol, SMTP protocol, right? Or the MIME format. All these are applications on top of your network TCP/IP layer, using TCP/IP and any physical layer. You can imagine the same similar structure or tiering on the right side on the AI. Natural language processing, dynamic or automatic programming, representing the knowledge, or intelligent bots, or all these MLs, DLs, etc., or their notions, for example, SVM, etc. They are sort of like HTTP, SMTP protocols or applications on top of underneath machine learning or neural network or deep learning layer, the foundational blocks, right? And the linear regressions and the classification, the logistic regressions, or the neural networks, or the convolutional neural networks, or the transformers, or your UDP protocols, TCP protocols, or your TLS, then your session layer, TLS, what do you call it, TLS, and then the other secure transaction layer, STL, etc., right? Or session session level security, STL, etc., right? I'm not going to spend a lot of time on the applications, the real world applications of the artificial intelligence, but I would like to give you a glimpse of various areas where artificial intelligence is already making waves or being leveraged, which would help you to get a sense of which area that you can choose as you focus on your undergraduate studies and as you start post your undergraduation, start building or embark on building your professional career, to give you some sort of guiding lights for you to start making your decision, right? It is pervasive. AI and application of AI is pervasive. A technology is not for the mere existence of showing off. It has to be, and it should be a utility to solve a problem, whether to solve a problem or to add value to either to the humans or to the business or to the society. Otherwise, technology in a mere sheer technology form has no meaning. Hence, it will find its way and people will leverage technology to create value, both for the people who use it, both for the people who create it to create the wealth to those stakeholders that invest in creating that technology or that business. Healthcare, it's finding out most accurate diagnosis by analyzing the patterns in the X-rays, cardiograms, you name it, right? And also personalized medicine, and then the therapy based on the historical patient information. CRM, lots of telemarketers, and I'm sure all of you would have received automated robotic calls trying to sell you something. Imagine 5 years back, people were calling so many humans. And today, probably 30% of that is done by automated calls. And today, the level of CRM, your telemarketing, has gone to that level of maturity that there are companies that can understand what you speak on the fly and respond back. And there are companies, and in fact, I tried to integrate one of those for my previous company to reduce the human cost and then the efficiency, or improve the efficiency of making thousands of calls in a day, right? Finance to identify frauds, manufacturing, I talked about Tesla and many other companies. Ola probably also is doing it in their electric vehicle factory, Gigafactory in Chennai, and transportation, self-driving cars, I talked about the Mahindra and many other companies, right? Agriculture, one of the areas not much invested, probably. Agriculture is the backbone of Indian business. And agriculture as such is less tech literate people laden business, right? And making the tech to be used by them seamlessly and giving them the benefits of the tech, particularly AI, would be something that most of us would love, in my view, giving back to our grassroots, right? Um, Somebody can think of building self-driving tractors that would help many of the bring down the labor and bring the efficiency, and also help most of the people bring the cost effectiveness, right, to cultivate, to farm thousands of acres or hundreds of acres or thousands of acres. Some of these areas you guys should seriously think about how to apply AI, particularly India-focused areas. And Government of India, and there are many private sectors that are VCs that are eagerly waiting to invest in such technologies, right? Be it education, energy, etc., right? Government in terms of bringing in the automated regulations, right? Security, frauds, and preventing the frauds, and then identifying the DDoS attacks, right? Entertainment, and we are already witnessing movies like RRR, movies like Kalki, wouldn't have been possible without AI, without machine learning. Absolutely not possible, right? You can recreate the whole imaginary world to be realistic. These movies have demonstrated that. RRR, Kalki, and many other Hollywood movies, right? Avatars of the world, right? Avatar has become, even though it's an Indian word, it has become a vocabulary just like Google, even in the Western world, right? Of course, the other less invaded area or less leveraged area is the law and legal. There are millions of judgments, millions of cases, and petabytes of previous cases, legal case history. And imagine building a bot to assist a legal advisor in bringing the relevant case for the case at hand, and also summarizing various points that were taken as the basis for the judgments, taken as the alibis in the past. Imagine that, how effectively it will bring in the efficiency, and then the democratize the justice, democratize the regulatory, or leverage the regulatory framework to bring the justice, right? And also rate of delivering the judgments or justice would be highly, highly desirable for countries like us, right? So I'm gonna quickly go through some of these because I've addressed most of these, but essentially the idea of this is, this picture here is to bring in various types of learning: supervised, unsupervised, reinforcement learning, deep learning, right? So all of you would know and are going to know, and particularly as we implement the projects, around 8 to 10 projects, and also as you go through your academic subjects in this semester and the coming semesters, these would become basic fundamental terminology for you. Supervised is where you are giving some data and what this data is labels. Unsupervised is you're not saying anything what this data is, but you are giving data without any labels. And reinforced is like your robot, right? You make a mistake and you made a mistake, so there is a reward or penalty, and then you use that to make the next step, or to make the decision for the next step based on your past experience. So we had this reinforcement learning in a crude way in schools, like you make a mistake, you will get, all of are familiar with our teachers when we grew up in schools. Some of you maybe, not this generation, but my generation, yes, there would be a stick and you would get a slap or a beating with a stick on your hand if you make a mistake. It's an expensive way of reinforced learning or reinforcement learning. But there are various ways, and these ways evolve. That's what Darwin said, right? So humans evolve. You start with a certain thing, which would be cutting edge, and state of the art at the time, and as you evolve, and that becomes a legacy and that becomes a crude when you look back. So reinforcement learning is essentially iterative learning based on having some sort of value to your decision that you made in the past. A penalty if it is not a right way, not optimal way, and a reward if it is an optimal way, right? So I would like to quote a particular quote from John Kahn, who is the chief scientist at Meta, Facebook today, and who is one of the deep learning pioneers. In fact, his invention or his iteration of back propagation, bringing the complexity down and using the gradient descent, probably stochastic gradient descent as well, effectively, in a deep neural network. His paper back in, I think, 80s, his paper brought in the needed trigger to start using artificial networks practically to build or to use them in solving the artificial intelligence challenges. His solution using the back propagation neural networks, the multi-layer MLPs and ANNs, to identify the zip codes, handwritten zip codes of the US Postal Service in late 80s, is the first step of practical application in an affordable way of neural networks. Probably this is very late 80s. And I need to tell a story about this as well. GPREC also has some sort of role that it played in this neural networks. College started in 84, I think, or 85. Even in 86, 87, the third year students, and I have gone through, when I was trying to peruse through all the project works for the final year, we had only 3 branches when I was in my final year, 1991-92, ECE, civil and mechanical. And I was perusing through in the library all the reports, project reports of my seniors, around 3 years. One of them struck my attention where I think it was one of my seniors from Gadwal, ECE. He has built a project using neural networks, artificial neural networks, to identify the patterns. I think it was visual patterns or text patterns, visual patterns. Imagine that even Polarity College was, students were trying to leverage the ANN back then. But then it was not prevalent because it was damn expensive to identify your learning parameters of each layer because of the most complex back propagation of your feed-forward network. But then Lee Kahn has actually made that easier. And his quote is what I would like to bring into you to you guys is, we don't need to teach machines how to think, but we just need to make them learn from us. We need to teach, essentially we want them to learn from us, or we need to teach them how to learn from us, right? I think we've pretty much covered the scheduled time. Probably I'll try to wrap it up in 10 to 15 minutes. Is that fine, Professor Suresh?
Sir, yes, sir. Yes, sir. Tell me, sir.
So we've reached the scheduled time of 12 o'clock. Can we extend
Yes,
for
sir.
another 10 to 15 minutes?
Yes, sir. That's no problem.
Right. So what is the result of machines thinking today? And this is something that I've created for you guys specifically. So all of you know on the left side, right? So you have training of the machines, various modes of training, be it text, be it data, video, audio, blah, 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 blah. You process. And then you select an algorithm and some parameters for that algorithm, like if it is a neural network, or some parameters. which we call them hyperparameters. And then it learns, and learning is nothing but tweaking those parameters and I having some values. And then it infers. So what is the output of that inference? So it could be a prediction, predicting with some probability. It's called soft prediction. Or let's say logistic regression is predicting this belongs to this cluster or the other. Or linear regression of predicting the value of, for example, a flat in Bangalore, HSR, Koramangala are most happening places. And in the past 5 to 10 years, whether it's a house or a flat, it has raised, the price of buying that flat has risen beyond 100%. So what could be its cost today based on the past prices? So you're predicting, it's a continuous or discrete value, which is logistic prediction. Classifying them, what categories, clustering them. And the other most important inference or the output of an AI or machine learning is generating what is the next possible text or video or audio or image. And that is what generative AI today is. These are called, the models that do are called generative models. And the other models like clustering and classification, predicting a value, they are all called discriminative models, except the predicting the values. These are the two classical models of categorization that are employed in the machine learning or in the AI as a fundamental algorithms, right? Descriptive models or discriminative models, generative models, right? So I'd like to spend a couple of minutes and a couple of key concepts that are fundamental as well as relevant to today. So the fulcrum, the core of neural networks is a neuron or artificial neuron, which completely, as you can see from this picture, mimics the human neuron. So human neuron essentially, or neurons have dendrites, and then as you can see, the input is dendrite and axon on the right side, which is the output, which connects to the input of or the output of the neuron and connects to the input of the other dendrite. And then the synapse passes, or your charge or your energy passes from one neuron to the other, and the level of that energy varies, right? And that is the connection. And that bridge is nothing but what we call it in artificial neuron activation function, which could be, it could be linear, like ReLU, the rectified linear unit, or non-linear. There are non-linear functions as well. Sigmoid, for example, is the non-linear activation function. And then what happens within the core of the nucleus of the neuron after it receives some inputs from the other neurons, or after it receives inputs, they get weighed or weighted, multiplied. Those are the weights. And they get summed up with some bias based on the energy level of that nucleus. And then they get activated using the synapse, essentially based on the gap between these two neurons. And that synapse is essentially your activation function in artificial neuron. And then it produces an output, becomes an input to the other neurons, not just one neuron, right? So this is the fundamental key concept behind the neuron, which gets repeated as a chain within a layer and across the layers, right? And that is essentially whether you have a simple, this neuron is essentially, artificial neuron is called perceptron. So you can have a network of perceptron, a simple input and output without any hidden, and that becomes a simple perceptron or simple network. Or you can have tens or hundreds or thousands of those layers, which is what today's deep learning algorithms have. So that's a deep learning network, right? This is a simple example with multiple layers, how an image is recognized, combining the neuron and then the mathematics, which is nothing but convolution, right? The convolution is nothing but, you must have learned this in your M2 or M3, is nothing but the multiplication of two functions, the output of multiplication of two functions. That is the key concept used in the convolution, and that is the key concept used in the convolutional neural network, where it takes and scans each bunch of pixels in the entire area in an iterative way, identifies the patterns which happens across multiple layers, and provides a classification or some result in the end, right? So I wanted to cover this if we had time, but I'm going to skip this. Key point that I wanted to bring out to you guys is the key behind any mathematical machine learning model is optimization, where when you are particularly learning or building a probabilistic model, you are going to hypothesize some output and you have some reference output, whether it's predicted or the real, and what is the gap between these two is the error. How do you minimize that error is minimization problem, which is in mathematics studied as optimization, and there is a subject itself, convex optimization. And there are various techniques to bring in whether a definitive optimization value or some level of optimization. There is a dual optimization techniques, etc. This is the key behind any learning technique in trying to learn. Back propagation is nothing but applying this minimization iteratively from backward output of your neural network, like you see here. Sorry, just a second. Applying this minimization for each neuron in across each layer, all the way from back to propagate it to the front, to your current input, right? And this is the key piece. There could be various techniques of SGD, GD, or just the gradient descent, etc., which you should have a clear grasp of whenever you get a time. And this is to go through it and get a good grasp of this optimization technique, because this is a fundamental tool for you as an AI student or AI engineer who applies AI to everyday problems, right? I was talking about it. In fact, recently we bought this from iRobot. iRobot is a company that revolutionized in the 80s and invented this Roomba, which cleans, automatically learns and maps your entire building or area without steps, and then vacuum cleans and also mops, and then goes back and sits into the charging station. Automatically you can schedule it. It identifies the obstacles. It has a 5-level camera with a light. It's super useful, at least particularly in today's world of where finding a human labor maid is very, very tough. It is at least 60% efficient in cleaning premises of your defined area. This is a classic example of reinforcement learning, where there's a risk and reward. It becomes super efficient over the time as it learns, right? So I talked about generative and discriminative model. For the lack of time, I'm going to skip this. I'm going to spend a couple of minutes in terms of the phases in the AI. So there are 4 phases. Currently, we are in the 4th phase. The first phase was the birth of it, where it was 50s to 70s, where it was more of, what should I say, more of rule-based automation as an AI. Second phase, 80s to 2006, was algorithms trying to learn and take out that imperative or rule-based construct from the programming and build programs, dynamic programs that can learn themselves based on the data and identify patterns and use them in inference. Phase 3, 2010 to 17, is make that learning deep using artificial neural networks. Now the fact that the expensive techniques or compute intensive techniques like gradient descent. Gradient descent is nothing but identifying how to reduce the rate of change of error to zero, which is nothing but your first derivative, right? Calculus. Now you codify your rate of change, how your error is changing from the past iterations. So you hypothesize into a formula, and then you take a first derivative of it, then you get the rate of change, and then you equate it to zero. Is nothing but where rate of change is zero is nothing but your bottommost or minimum point of that rate of change. And identifying that is using gradient descent or first derivative, equating first derivative to zero and identifying your vectors values. In our calculus, we used a univariate variable x, hence we call it as first derivative. But whereas when you use a vector of multidimensional, today ML techniques use 20,000, 30,000. I think OpenGI uses around 24,000 change dimensions. So that many dimensions, that many variables, it becomes a gradient instead of just first derivative, right? So it has become cheaper with gradient or descent or SGT. Hence, the proliferation of the deep learning techniques or deep learning algorithms, and then slowly the generative AI, where you can predict the next word based on the evolution in NLP started occurring. And then that gave rise to something, an invention by an Indian called Vaswani and his colleagues at Google DeepMind called Attention is All You Need, which is the birth of a transformer technique, which essentially mimics paying attention, which is what our professors say, right? When there is a class, pay attention to every word, not only now in the past 1 minute, but every word that has been uttered in the session. Then you have learned that and you can apply that. And that is what essentially is part of your transformer, which is a basis for GPTs, generative pre-trained transformers. And that is the current generation or current bleeding edge, right? Well, I'm going to skip this, probably for some other. So how did it become, even though AI neural networks existed in the 80s, even GPREC students were trying to build some prototypes and projects, but how did it become now in the past 10 years so widespread, prevalent? Is because of 4 to 5 factors. All of these involved expensive compute and memory, which was not possible at the time. You needed to buy outright these expensive computers, thousands of computers, right? And of course, it's not easily available, right? And then, of course, there is a continuous improvement of AI algorithms. And of course, the invention of attention, pre-training, building the LLMs, right? So today, compute is available to you, thousands of servers, without any upfront cost. You can hire them for 1 week, 1 day as you need. Elastic computing from AWS, Google, Azure, right? And the compute itself, the speed has gone up and it has become cheaper. And then there are purpose-built TPUs, tensor processing units, AI chips, etc., GPUs, right? So all these are the enablers that made possible what was not possible with neural networks back in 80s. Right? So this is a little evolution of various concepts and the algorithms, particularly towards the generative AI. NLP started with n-grams, number of words that you can pack them as a context window, and then converting them into a vector, because you need to know the context, under which context that word is being said. For example, if you say bank, it could be a financial bank, or it could be a river bank, ocean bank, right? Usually river bank. So you have to distinguish the meaning of bank in that sentence based on the context. That's the word to vector. And then, of course, you have to remember your past, which is your recurrent neural networks. You have to keep feeding the past data, and long short-term memory. How long will you remember? And then attention mechanism, the transformers, and then the bidirectional, both sides, and then the GPTs. And now we are at GPT-4, GPT-4, 4M, 4T, right? Large language models, essentially. So GPTs and LLMs are the basic building blocks today that a developer can straight away start using, like an API, to build applications. Just like you have today your RESTful endpoint HTTP as a one call by importing that library. And then you make a call to your web server, just one line of code, right? Or 2 lines of code. In the same level of abstraction is what GPTs, LLMs are built today. You don't have to really worry about building and getting all that. If you are determined, within one day, you can build application using GPTs and LLMs. And most of these are available to you as an open source, or even as a commercial with million API calls at $10 per million API calls. Even most established closed source LLMs from ChatGPT or Cloud API, Cloud API, you name it, right? So I wanted to kind of give you a glimpse of what is GPT and then what is LLM. So GPTs are your foundational blocks, transformers, multi-layer transformers, hundreds of layers, billions of neurons, billions of parameters. Each neuron has one parameter, right? Or bunch of parameters. They're all packaged, learned, pre-trained and learned, which you can fine-tune by learning your domain-specific data. And then you can start generating data across multiple models, right? Text, audio, video, speech, blah, 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 right? So LLMs are a notion of packaging not only GPT, there are other mechanisms that you can build these pre-trained models or language models. GPT happens to be one way of, or popular way of doing it. So you can use them. It could be LLM GPT is available to you at a cost. Meta's Llama is open source. A bunch of Bloom is open source, Hugging Face, right? You can just build LLM-based generative AI applications like in a snap today. All of you guys should seriously think of that level of building or leveraging the existing API infrastructure available to you, even from your village today. You have the 4G, 5G, you can access them. You don't have to really worry about, I'm not in Princeton, I'm not in Massachusetts, now I don't have the infrastructure. All this is available at a cost of few rupees of internet prepaid package from Reliance or from Airtel, right? Right. So I'm going to quickly walk you through some sort of complexity of these LLMs. We'll look at the GPT, it has 175 billion parameters across 96 plus layers of hidden layers of neural networks, of transformer layers. It has been trained on 300 billion tokens. A token is nothing but a sort of word. 4 to 5 letters make up a token. And then it is trained The compute used for training is so many 10 to the power of 23 floating point operations. You can imagine. This is few months of training. Cost GPT-4 cost OpenAI to train completely end-to-end, pre-processing and collecting this data around $100 million. All of that is available to you at a few cents per API cost or per million API cost. You can make use of it. It's like, if you have seen some of you guys Matrix movie, whenever Keanu Reeves wants to, let's say, do a sword fight or a gunfight, he would download that package. Probably a few years from now, machines, we download the package when we need. And that is the paradigm that we are moving to. So GPT is like a general purpose intelligence. You can download it and build your business function specific intelligence, knowledge, training, fine tuning on top of it, right? So I'm going to skip these. What are the closed and open source? The open source you can see here, Bloom, Metas, Llama, CodeGen, and some of them, GPT Neo, they're from OpenAI itself, Google's BERT, right? And Vicuna, etc. And of course, closed source there are many of them, Chinchilla, Gopher, Lambda, Google's, right? Alexa TM, Cosmo. In fact, India also has last three. Ola has announced Krithrim, Bharat GPT, Sarvam, Open Hathi. You guys should try some of these. These are all available already as an API. Some of them, not all of them, right? So I've already talked about it. This is just to give an idea about OpenGPT. GPT-3 is trained on what type of source, how many tokens you can see here. Open crawled data around 410 billions, which has around 60% weightage in the training. And web text, 19 billion tokens. Wikipedia at 3% of weightage training, 3 billion tokens. So essentially the sources that it is trained on, crawled data, books, research papers, code repositories, GitHub, open source repositories, SourceForge, etc., curated web sources, some of these dialogues between, customer service dialogues, which they have taken permission to ingest and train on, news articles, etc., right? Another 5 minutes, we'll wrap up the session, guys. So I'm going to skip the state of the art. I kind of talked about it. All these are available to you, to us as technology professionals on a platter with an API call away from your Visual Studio Code environment. Make use of it. Leverage this state of the art. Try building solutions that add value or solve a problem to business or to the society. So other term that I would like you to introduce to you guys is explainable AI. Most of the AI today, particularly closed source, which is old days, you do not know the internal decision-making process. And that would be dangerous, right? It's like what goes inside to make a decision. And if it is used in an autonomous way, for example, to fire a missile at a border, it would be dangerous. It would be catastrophic, and it could trigger third world nuclear war. So we need to have the transparency of explaining what is the decision making by that AI agent. And that is the next subfield that is gaining momentum, particularly invested, regulated, and led by the governments and societies, charitable trusts, etc., across the world. Healthcare, autonomous systems, and also making use of it in sustainability. For example, Google's DeepMind has built a energy efficient cooling framework centers, and then the framework to bring that cooling infrastructure. IBM's Watson for identifying, oncology, the cancer, etc. the X-rays and other diagnostic information. Right. So, like I was talking about, the dangers of AI, and some of you have already witnessed with one of this popular heroine from Bahubali, or one of, I think, Kannada girl, deepfake, she getting into a lift, I forgot her name, or the privacy violations. And then genuinely, there could be some job losses if the people don't go to the next level, right? So it is an evolution, right? Survival of the fittest. Those that can't adapt would definitely go into oblivion. And that time and again it has been taught, and Darwin has been telling it since, I don't know, since how many thousands years, 100 years back, right? And of course, social manipulations. You've seen the power of social media with chatbots on X, Twitter, etc. Even in today, in US presidential elections, how they are using the bots to run a propaganda campaign, whether Trump versus Kamala or Kamala versus Harris. This is being used. It's a fact, right? It needs to be regulated. And then, of course, people can manipulate the Sensex and then the market, equity markets. Autonomous weapons, they need to be, definitely, if they're used without transparency, it could trigger catastrophe, right? Completely obliterate the entire world, humanity, because pretty much top 5-6 nations have the nuclear power, and a bunch of nuclear weapons are good enough to eradicate the world. And I'm sure some of you might have seen and correlate to the latest installment of Mission Impossible, right? Dead Reckoning Part 1, Part 2. These are, while imaginative, they're not completely hypothetical. They do stem from practical situations that could hypothetically exist, right? So limitations is, again, we talked about it, transparency, some of the bias that comes from, for example, if a machine is getting trained with, let's say, all the articles written by a particular party, political party in India, and an AI is trained based on those articles, most of those articles by that particular party, naturally, that AI will have bias towards the principles and then the promises and then the thinking of that particular party, and may jettison, may ostracize other rational and democratic values of the democracy or of the humanity. So that bias and discrimination is super dangerous. And it is a limitation today that bias need to be removed out of the pre-trained models, right? And of course, privacy concerns. And if today these LLMs are only in top 3-4 companies: Google, Meta, OpenAI, Microsoft, and a couple more. Imagine these guys having a superpower with these machines. They could collude and then probably go against the world. So the power is concentrated, hopefully not, but then AIs can bring that concentration of power, and we need to ensure that power is not concentrated, and it is regulated, controlled, and democratized, right? And of course, it can be used to bring in, taking out the inequality, economic inequality, and bring in the economic equality, right? Future direction, essentially, generalized and multimodal AI systems will become prevalent, and AI becomes explainable and efficient and scalable, and it would be available at a touch of a button, partly which it is today. And it has to build, and it will build ethics into its embrace ethics and fairness and responsibility. Of course, there would be domain-specific, business-specific AI applications that would build on top of the LLMs and then the GPTs. And we need to encourage, and it would become one of the fields in applying AI for the social good, the human collaboration. And of course, governments and then the states across the world would invest heavily in bringing in a governance and a regulation framework for the AIs which would be completely tech driven and become a part of each AI, LLM, and GPT that everybody and anybody builds across the globe. And of course, all of these would drive a next generation AI architecture that would be plug and play and that would be modular. So my view is that general artificial intelligence would become a pervasive and ubiquitous API utility. You might have heard about API economy. Today, any software business is called as an API economy value creation company, because you don't buy software as a license today, you buy an API access today. Hence, it is an API economy. In the same vein, general artificial intelligence would become as pervasive and as ubiquitous as today's RESTful web endpoint, HTTP endpoint, not far away from today, right? So a couple of minutes on the applied AI and ML industry projects lab. So of course, the idea and the benefits are, it helps you build practically the machine learning, building blocks of machine learning algorithms using industry and real life data, practically guided by the mentor, myself, and of course, also by Professor Suresh. And these would help you build a pragmatic understanding of the application and also help you build a bridge with the industry and understand how industry is applying the AI in solving current business challenges and leveraging the AI. The algorithms that we would be addressing for the projects would be 6 to 7. They are also explained in the first course handout. I hope all of you have access. The prerequisite, of course, is a little bit of linear algebra, probability, calculus, and a bit of understanding of optimization, convex optimization, which kind of I addressed a little while ago, right? The structure is essentially, it's again addressed in the FCH. So next week's project would be announced on Monday, 8 p.m. through WhatsApp group as well as the Google Classroom. And then I would expect you guys build the understanding of that particular algorithm and make your hands dirty by building some rudimentary model by Saturday. So Saturday is where I would address the theory and I would recap the theory of that algorithm and answer the questions on the project. Any questions for you to implementation questions. So we would have given the project name, algorithm, data, and what is the problem statement on Monday itself. Saturday is the summary overview, recap of the algorithm, and answering the questions for the implementation. Sunday, if some of you want to demonstrate what you have implemented, we would dedicate 15 to 20 minutes for 4 or 5 people to demonstrate. And the rest of the time, I'd help you guys implement that if some of you have not implemented, and have an interactive, walk you through the code and have an interactive session on the implemented code, and then the implications, and then the interactions, and then implications, and then the value of that particular algorithm in the industry. And then by Sunday, midnight, 11:59, I would expect all of you who join this course and enroll to this program to upload your working code, which is a Jupyter file, to the Google Classroom. Professor Suresh has already assigned these assignments, 6 to 8, to all of you. We would expect you to upload before the deadline of each Sunday of that weekly. So we would be running these sessions, interactive sessions, through, this is a paid subscription of Google Classroom provided by my company, Brilliant Technologies, which would support 150 participants. I think I've seen 135 students have participated. The Google Classroom's limit is 100 students, as we had to get this to you guys separately. The link of this is the generic link going forward would be provided on the Google Classroom portal itself. For any questions related to the program coordinator and then the lab coordinator is Professor Suresh. And I'm going to run or invite you guys, right, to to a particular action or item that if any of you are interested in building an application, a Gen AI application, I'd be happy to guide you guys or give you a problem statement. Reach out to me on this email address. So this deck would be shared in the Google Classroom. So you would not have to make a note of this email address. So let's go to questions and answers. I would highly recommend you guys ask any questions. Originally I started out 10 minutes, but I think for the lack of time, we will start out probably 5 minutes. Professor Suresh, students, any questions?
Yeah, guys, if you have any queries or any doubts related to this program, you may ask, sir.
Or any question related to AI, not only about program. Learning is faster, efficient, quicker, and will get retained permanently only when you ask question voluntarily and get that question answered. That has a higher rate of retention in human mind, guys. Please ask.
Sir, one question related to the program.
Yes, please.
Yeah. So like at the end of the course, like whoever successfully finish the course and submit the projects, they will be receiving the certificates, right, sir?
Correct. That is true. I missed that.
Yeah. So here in this context, do all the projects are to be completed, or else like maybe one or two, if they doesn't work out, also they will receive the certificate.
I think we'll take best 5 or 6 that you and I can identify and communicate later.
Okay, sir. Okay.
Is that fine?
Yes, sir. Yes, sir. It's fine.
Students, was it too much of information? Were you guys able to follow? Say something, guys.
Yes, someone you can like speak, unmute yourself and you can speak.
Ladies and gentlemen, it's a Sunday afternoon, still feeling sleepy, not interested in talking. Interesting. All right. Anyone want to ask any question, guys? Okay, looks like someone is going to ask. Go ahead.
Sir, good afternoon, sir.
Very good afternoon.
Sir, sir, all the concepts that you are mentioning, actually we are learning no, sir, in our curriculum. So we don't have utmost knowledge about anything, sir. So it's better to teach somewhat slowly.
Absolutely. Would
Sir.
address. Absolutely. It's a good question. So I think 3 to 4 algorithms some of you have, for example, linear regression, logistic regression. I remember seeing in the course curriculum that I was shared with, but absolutely your point taken that I would provide the overview of each algorithm on each Saturday.
Thank you for responding my query, sir.
Anyone else, guys? Any other question, guys? No one? So was it too much, Suresh, the content, and too fast?
Not exactly, sir. Not exactly. Maybe I guess the question which Vishnu asked just now, that must be a common question for all of them, if I'm sure. Anyhow, like they have started these courses just now. So hopefully, once they start working on it, definitely they will get the questions. That is my understanding.
Absolutely, no doubt about it. But I was just trying to assess whether was it too much of information in today's session.
I guess no, sir. No,
All right.
because you conveyed all the basics, and I felt like it's an introduction, like what they are about, like going to learn regarding the core. Actually, that's what I felt.
Right. So I would really request any one of you guys share your thought or your feedback about this session. Was it too much of information, too fast? One of you guys at least. Don't
Yes,
feel shy.
you can unmute yourself. You can just let sir note the feedback.
So if you guys don't speak, I'll make each of the session this heavy. So better share your thoughts, guys. No? All right. No worries. No worries. I can understand. So let's wrap up with the next slide. So call to action, guys. Like I said, there is no stupid question. Well, I did not say it, but I'm saying now. Ask questions. The best effective form of learning is asking questions, and there is no stupid question. I truly, genuinely believe that. Right? Also, even though you might not have learned so far, spend some time in learning the algorithm of that project. Spend few hours, because for you as computer science specialized AI/ML or AIUP engineers, branch engineers, these, if you are looking for a career, these algorithms that you are going to build projects around are fundamental. They're like alphabets of English. You can't speak English without knowing alphabets. So it is worth spending few hours in the week about each of these algorithms before, and also try to make your hands dirty, right? Before, or rather not waiting for Saturday, right?
Sir,
Go ahead, please.
sir, you actually told we need maths for AI. How much we actually need?
Well, it's just some basic understanding of algebra, linear equations. You really don't need any complex math at all. What is the probability? For example, naive Bayes builds on a conditional probability, right? So conditional probability, the father of conditional probability is Mr. Bayes or Bayes theorem. Probability of an event A occurring given B has occurred is equals to probability of, or prior probability of B occurring having A occurred multiplied by prior probability of A divided by probability of prior probability of B. These are the fundamental mathematics of probability and algebra, linear algebra. For example, in linear equation is, AI multiplied by, or WI multiplied by XI, which can be written as, matrix and vector multiplication. A vector is nothing but your multiple dimensions. These are the basics. In fact, so way basics that they are even taught in our 10th and 11th, 8th, 9th and 10th class today as well. So those are the basics I'm referring to, not any complex proficiency. That helps?
Yes, sir. Thank you for.
Any other question, guys? Vamshi, was it too much of content today or was it okay?
Okay, sir.
Okay. All right. So spend some time, understand the algorithm of the week for the project, and ask questions, implementation related. On Saturday, as well as you can post questions on the WhatsApp group or on the Google Class group. Probably, I'll discuss with Professor Suresh. Should we restrict the questions only to Google Classroom, etc.? But feel free to ask questions in the offline digital form, not offline, digital channel, whether WhatsApp or Google Classroom, right? Attempt implementing before Saturday, whatever the possible. Do not build some sort of phobia. Don't wait for auspicious time. Do something, put some code. All of these algorithm projects do not require more than 100 lines of code. That is a fact. Not more than 100 lines of code, core code. And each algorithm, plotting may require 100 lines, 50 lines, but the core algorithm is not more than 100 lines. Like I said, it is an API call away, each algorithm. All you need to understand are what are the hyperparameters, what are the input parameters, and what we want, right? And also seek help to complete the project on Sunday session and upload by Sunday midnight. So that's about it. I think I went beyond 15 to 20 minutes more than the slotted 1.5 hours. My apologies for that. But I believe it gave you some glimpse about the past, present, and future of AI, and some idea about the power of AI for your professional journey, what type of tools and what type of projects that you are going to do in this program, and how they can help you to embark on your professional journey. I hope it helped in these aspects and angles for all of you guys. So with that, Professor Suresh, we could close this session unless you have anything else.
Yeah, nothing much beyond this, sir. It's like as the things goes on, definitely we'll be getting more and more doubts and more understanding may be required regarding the course as well as the algorithm that they are going to implement, if I'm sure. Yeah. Thank you, sir. Thank you for the basic session. It was very clear and you took it like almost revolved around the basics. And the things are clear for students.
Thank you so much.
Yeah.
All of you have a great weekend ahead.
Thank you
too,
so much.
Professor. Thank you.
Thank you so
Bye-bye.
much, guys. Bye.